Okay, we're taking a look at the ideal gas law right now. And so once again, everything's cumulative. We started out separating pressure and volume, pressure and temperature, volume and temperature. Then we brought everything together into one law. And now what we're doing is we're bringing one more thing in. We're going to bring in moles. Now, a lot of times what happens is we use moles equals mass over molar mass with this law. But right now, we're going to ignore this with the questions we have, and we're just going to use the formula PV equals nRT. So what is pressure, or what is P? P is pressure. It must be in ATMs. Pressure must be, sorry about that, folks. Pressure must be in ATMs. If it's given to you in millimeters of mercury, you must multiply it by 0.13 to get it into ATMs. Volume. Volume must be in liters for this formula to work. So if it's in milliliters, you're going to divide it by 1,000 to get it into liters. N is moles, so this will be given to you on the 6 questions you have today. Sometimes you have to figure it out using this formula, but today it's going to be given to you. Let's skip to temperature. Temperature must be in Kelvin. It's degrees Celsius plus 273 to get into Kelvin. R is a constant that ties together the units for temperature, volume, and pressure. It is 0.00821. I didn't write the units in here. I'm not going to confuse you with that, but whenever you're using ATMs, kelvins, and millimeters of mercury, whenever you're using ATMs and liters, so kelvins, ATMs, and liters, you must use 0.0821 as your R value, your constant. That's 0.0821. Let's try a problem. If 2 moles of a gas at 27 degrees Celsius and under 700 mmHg, millimeters of mercury, of pressure, what is the volume of the gas? So when you get an ideal gas law problem, and you'll know when you have one because you'll get moles, write down PV equals nRT. Your pressure, remember, we have to take that 700. If it's given in millimeters of mercury, we need it in ATMs, so we have to times it by 0.0013, and we will get 0.91 ATM as our pressure. Let's take a look at our volume. Our volume must be in liters. So it's asking us for our volume, so that's what we're going to figure out. We have 2 moles, so we put 2 in. R is always 0.0821, and our temperature must be in Kelvin, so we have to add 273 to this. So when we do that, we will get 300 K. We need to rearrange the formula, so it's going to be 2 times 0.0821 times 300 divided by 0.91. So I'm going to go ahead and figure this out. So I have a volume of 54.1 liters. Remember, your answer is always in liters. The most important thing I can emphasize here is that pressure must be in ATMs, volume must be in liters, temperature must be in Kelvin to be able to do this. This 0.0821 goes into every single question we do. It is a constant. And our moles will be given in moles. There's no other conversions that have to be done there.